Hey, welcome back. This is the 12th and last Shoptalk episode for 2015. And I hope you all had a great Christmas and a few quiet days over the holidays. And next thing will be the leap into 2016. So I started this channel, or at least doing videos that are proper edited with me talking and explaining about pretty precisely 1 year ago. And my first big project I showed were the 3-jaw chucks, where we did the teeth on the pantograph, and people pretty much liked this. And due to the great feedback I got, I kept on doing it, and now we're here 1 year later. I have over 6,500 subscribers, and I get so much great feedback on every single of my videos, and I really enjoy doing this, and I will keep doing it as long as it's as I enjoy it, and as long as it's fun for me. And as long as you keep the good comments coming and the great feedback, that's thank you all. So what do we have today? First of all, you might notice that the camera is at a completely different position, and I made myself a little rig, and I'm going to show it to you. Okay, this is something not everybody might be interested. For filming the videos for my YouTube channel, I use this Manfrotto Tripod. It's a Manfrotto 190 X Prop. Pretty nice tripod. 3-way swiveling head on top here, and with a quick change mechanism here. So you can take your camera with just by opening this one lever, and you can take off the whole camera. And this is a very nice tripod. But as you can see, it has quite a large footprint. It's about 1 meter across. And you can imagine when you're working in the shop, you're always tripping over the tripod. The guys who do also video might feel with me. The tripod is always in the way. I have seen a lot of great builds with camera cranes and ceiling hanging jigs and stuff like that, but I was thinking I could use something else. And we're talking about this. This is a big Noga arm. I got this used from my used machinery dealer for about $5. I had a canned twist clamp. I welded the Noga arm to the canned twist clamp, and I added up here a Manfrotto quick change plate. So I can set my cameras with the quick change adapters in there, and I will go and show you how I use this, or I plan to use this. Okay, and the way how this works is you take this arm with the clamp, tighten it down to the wherever you want it to be, and you can move it like you need it. This, tighten it down, nice and solid. Take your camera. This is my secondary camera, the EOS 700D DSLR. Not really meant for video, more for still photography, but it still takes pretty good video also. And it has also one of the Manfrotto quick change bases, which just go in there, click it in position, lock it, get the hand strap out of the way, and you're good to go. You can adjust it however you need it, lock it, and do your whatever you want. And when I looked for this camera, I especially took one that has a tilting display, so I can tilt the display out, set it to live view, and get a live image of the camera on the screen, which my old DSLR couldn't do, which also hadn't a tilting display. And main use for this will be on the machines. I can clamp this to the shelf above the lathe. I had always a hard time to film lathe work because the tripod is really heavy in the way when you do lathe work. And with this I can get the camera completely out of the way. And also on the milling machine, I think there is a shelf that might give a good view on the tool next to the milling machine. So let's go over to the lathe and see how this will work out. Okay, same here. I clamped the arm to the shelf above the lathe. Really good. Clamped it down good. Get my camera in there. And lock it in position. Flip out the display so we see what we're doing. This gives a good view on the lathe chuck, and now with the two cameras set up, I can do, I think, pretty interesting stuff, and I hope that I can show, for example, on the pantograph machine, the tool motion and my hand motion on the template table at the same time, or show the hand cranks of the machine while I operate them and the movement of the tool at the same time, just stuff like that to make the video a bit more interesting and a bit more storytelling or fact-telling. But really these are still instructional videos, so I won't go crazy on the videography. I think I found something like a style for my videos, and I want to keep it. I want to do down-to-earth projects with where I show a lot of the actual machining with explanations, and yeah, I think that's why the people watch my stuff, at least I hope, and not because I goof off on camera. So that's the magic arm. Oh, well, because I say magic arm, Manfrotto sells something like this with a super clamp on one side. That's their. It looks almost like a twist clamp, twist clamp, but it's made of plastic, with a Noga arm and also a quick changer on the end. But it's pretty expensive, and I hesitated to buy it, so I made my own. You saw the magic arm. My magic arm rip-off, and it has proven quite useful until now, and I'm very happy about it. And it was really very little effort to set this up. And it will find quite a lot of use in future. You can see that right now you're looking at the milling machine, and I want to do some time-lapse when I do longer projects, and just have the camera running and edit it afterwards into a compressed version of a whole project, maybe. Another little segment, I had to turn to plastic discs, and I did this on the lathe, of course. And today we are working with plastics. I needed 2 discs made of acrylic glass with a diameter of 133 millimeter, and of course I didn't have round stock acrylic round stock in the shop with that diameter. In fact, I don't have any round acrylic in the shop. But what I have is sheet material that's thick enough to cut the discs. And to do this, I laid out the circle with the divider, cut it out with the jigsaw with a very rough toothed wood blade, and then I center drilled. I put a center drill on the drill press into the center where I put my dividers. And the next step is straightforward to go on the lathe, and I will show you how you can make a nice round disc out of a rough sawn piece. As you can see, the lathe is already dirty from the first disc I machined, and we absolutely need no special jig for this operation. We only need some double stick tape and a live center in the tailstock. We open the jaws of the 3-jaw chuck up to some convenient diameter. In this case, about 60 millimeter circle around it. It doesn't really matter. A bit more wouldn't hurt, but I'm not in the right mood to change the chuck jaws right now, and it works that way also. Then you take some denatured alcohol and clean your chuck jaws. The face of your jaws needs to be somewhat free of oil and grease. You could also use acetone, but the denatured alcohol does the trick most of the time. And then you take your double stick tape, put a piece on there, and cut it off. If your jaws are wider apart, you have to cut 3 pieces of double stick tape, of course. And you peel off the protective paper from the double stick tape. And that's all preparation you need to do this setup. And you bring in your tailstock, loosen up the quill, and you set the center bore in the rough sawn disc against the live center, and then you just push the disc against the chuck, against the double stick tape, and lock it in place. That's all set up. Now we can turn and machine this disc as we want. And I will show you that you can take quite a cut with this setup. This is a pretty safe setup. As long as the tailstock doesn't move away, this disc can't slip out because it's held in place by the center bore. You take a nice cut. There you have it. Now we have a nice round disc without any special jigs or nothing, just a piece of double stick. Now as we have the final diameter, we can take our chamfering bit and put a nice chamfer on there. And to release it, you just pull back your lathe center, get the tailstock out of the way, and use a soft hammer and knock it off. There you have it. A nice round disc in about 5 minutes. And if you ask what these plastic discs are for, I will show you now. These plastic discs became tool carousels on the side of my milling machine. I didn't show this in video making. It's just an arm with a piece of round stock welded into it, 2 ball bearings and 2 plastic discs, and it holds my regularly used Morse taper 2 tooling, and down here my Morse taper 2 collets, rated up to 20,000 RPM. And the last thing I wanted to show you, a lot of people asked about the projects I did during apprenticeship, and I dragged them out and I took a short video. Okay, these are some of the projects we did in apprenticeship, and I'll go over them each one by one. When you do an apprenticeship in Germany and you learn trade, you go in big companies. They have an apprentice shop and you do apprentice projects. The apprentice projects are just to build skills and to learn certain types of operations, like bench work, filing, sawing, using a drill press, center punching, sawing, and so on. And these are all bench projects. The machine shop projects, I have no idea where they are. We will build a small vise. But these are the bench projects we did. And the first of all projects was to file a block square. We got a piece of steel about 50 by 50 by 30 millimeters in dimension, and we filed it. It was rough sawn, mild steel, and then we filed it square on all surfaces. Then we filed it to a certain dimension on one dimension, in thickness. And that was the first project. This was to learn how to file square and flat, and to a certain dimension. But I can't find the block we learned filing on. I think I used it for another project. The first project that was not only filing was this. This is a layout exercise. We got a piece of flat steel. We filed it square all around. Then we blued up the surface and we did some laying out a circle, a hex, tangential lines, and so on and so on. On the back side is some hand stamping, which I will not show you because it gives away some personal information you don't need to know. I can show you this. It says my name and Metall Grundausbildung. That's basic metal project, but it might be a bit hard to see on camera because of the glare. But that was hand stamping. We draw out lines and we hand stamped it, and then we took a file and equalized the material down to be flat again, because the stamping always throws up some material, and that looks like amateur level. Next project was this thing. This is a sawing exercise. We got again piece of flat steel. We did not file it square. We did some layout to it, and then we hacksawed the contour. We didn't file it. We only filed a big chamfer after sawing onto each side. Of course, the radii were drilled out. We drilled it, then we sawed in 2 times. This big cutout was chain drilled and chiseled out and then filed to a very close. Yeah, that was a sawing exercise, and the sawing was about to a tolerance of 0.5 millimeters. So yeah, this was sawed to. Nominal dimension was 15 millimeter, I'm pretty sure. Same in this direction. Yeah, it's a bit hard to measure. Yeah, 15.3. Okay, that was the sawing exercise. Then we did some work with, this is aluminum, just to see the difference to steel. We get a piece of aluminum, we filed it square, then we filed the radii, a chamfer, we drilled, tapped some holes, counterbore, countersink, just to see how the aluminum behaves. And we quickly learned that filing aluminum is not as much fun. We also did some work in plastics. This is fiber reinforced phenolic. Tufnol is a common name for it. Very nice material, very robust, nice to machine, but filing is not that great. So we got a blank sawn on the table saw. We filed it square, chamfered it radius, then we drilled it, counterbored, countersink, tapped, and also we did a big metric fine thread in there, hand threading. These were the little, pretty fast, pretty easy projects. This was the first big, yeah, let's call it challenge. This project consists of 2 plates of steel, flat stock, filed square. Yeah, got a bit rusty here. And we learned how to drill precisely, step drill, ream. We reamed a few holes, and the 2 plates are doweled together with dowel pins and a roll pin. We did a lot of tapping. All these holes are tapped and drilled through. Okay, not all. These are blind holes, tapped. A row of counterbored holes, countersink holes. These are just sitting flush on top, and this is a through hole connection with a nut on the back side. And this was really learning how to do a proper screw connection, how to install dowel pins properly so they don't seize up when you drive them in, and just getting the basics. But still pretty simple project. Filing a radius on here. Radius filing is always very nice. It's very easy, and you get a pretty good result when you have some exercise. We did also a lot of sheet metal bending. We learned how to bend strap brackets like this, and also we learned how to bend pipe clamps like this. A single clamp and a double-sided clamp to hold piping or thick cabling in place. We did spring turning, bending springs and hardening and tempering them, silver soldering, brazing, basic welding, some TIG welding, and yeah, really the absolute basic stuff. Then we have a bigger project. Again, this is only bench work, only cold drawn steel, sawed, filed, drilled, screwed together, and this has really no proper use. It's just a off-center cam that moves this plunger in here. The turn parts were done by the apprentices the year before us, so we could start without doing machining. At the end of our apprenticeship, we made again these parts for the next apprentices that came. And yeah, this was a pretty neat project. Very useless, but you learned quite a lot. We also wound the spring in here. We bent the sheet metal cover. And yeah, useless piece. And this is the most complicated mechanical part we made. Also completely useless, only an exercise. This is where we learned how to fit two pieces nicely together. The V cutout and the V shape on this movable part here are very precisely filed and checked with dial indicators and checked against light to get a perfect blackout fit. And this is really dead nuts on. And we also drilled and filed this L-shaped slot in here. Neat project, completely useless, but I learned quite a lot doing this, fitting up a V, getting things nice and flush out here. So, apprentice projects, really, most of them are really that useless. Oh, I almost forgot. As I said earlier, we also did a lot of plastics, and this was a combined mechanical and electronics project. This is a continuity tester. The box is made out of polystyrene. We get it as 4mm sheet material. We cut it up. We drilled the hole pattern. There's a speaker behind. We filed the cutouts for the switch and the LED, to connect the posts, and we will open it up to see inside. This was a pretty interesting project. We glued the box up from different parts, then we filed everything flush to each other, then we cleaned it up on emery paper, and then we sandblasted the plastic, and this got this nice surface finish. And here you can see the internals. There is a small board in there with the circuit, which just gives a beeping noise if you have a battery in there. I have no 9-volt block battery here in the shop, so I can't show it to you, but it just makes a sound when you connect these two posts to each other, and it's to check continuity. And yeah, this was a pretty interesting project because you did a lot of different things, and you were working with plastics instead of metal. And I have one last big project to show you. Okay, this is the biggest project we did in apprenticeship. This is a basic lab power supply, adjustable voltage and fixed current. So it's of limited use, but still it's adjustable voltage. So for many stuff it's good enough. And we built this completely from scratch. The housing is made of the side walls are plastic. This is 6mm polystyrene. The front and back panel are aluminum. We CNC engraved the front panel, and the back panel is manually machined on milling machine. The top and bottom, let's take it out. These are cut out of sheet metal, and we bent them to make them a proper cover, and we did the engine turning on them. If you don't know how this works, you have a elastic grinding point in the drill press, and you just walk on to touching down with the grinding point onto the surface and doop, 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 do this neat pattern. If you have a fence on the table of the drill press, it's easier, and then you get this pretty even, pretty neat surface. Looks kind of cool. This is aluminum sheeting. We bent the handle from stainless steel sheet metal, and we covered it with a big shrink tube. The nice brass shoulder bolts on the side here are machined. We turned them during machine shop course, and yeah, and these are the internals. Of course, the transformer is a ready bought one, the same for the displays. And the components, of course, are also bought. We have the board in there. This is etched in our electronics apprentices do the board. They do the layout and the etching. My trade doesn't learn how to etch and lay out boards, but we did the component placing, the soldering, and the wiring, which is not that great. Looks a bit messy in there. And we wired everything up. Then we did a proper testing. We checked it for electrical safety, so nobody dies when they switch it on, and doesn't turn out the lights in the house when you switch it on. And this is a pretty this has given me great service, and I use it quite a lot in the shop. If I have to just light up a LED or turn a small motor and stuff like that. This was a pretty neat project, and this took quite some time. Our apprentice teacher who did the mechanical part, for the housing, was really very picky on the quality we did, and this is okay. But still, I'm quite happy how this came out, and I have this always in the shop, and I will keep it, and it's a great reminder of how I started in the trade. So that's our apprenticeship project, and now I have to screw and close this housing back up, and it's all screwed together with nice countersunk oval shaped screws, and it's just a neat package. It's powered via one of these IEC connectors. Switch back here, fuse, the power transistor is up here under this cover with the big heat sink. And yeah, this was quite a neat project. So I think that's enough for one Shoptalk episode, last one this year. And I just want again to say thank you to all. I wouldn't be here without you, my commenters, subscribers, my viewers, all of you. Hope you have some quiet days and get good into 2016 and have some time off just for you and those near and dear to you. So be safe. Thank you all for watching. See you next year.